In this video, we will go through an example to how to develop the Ybus from a small grid system. Here we can see two diagrams. The upper one is an impedance diagram, and below is the admittance diagram. So you traditionally just know the impedance values of the system, and you also maybe have the voltage here. Here is the value of E1, for example, the voltage, there E2. Then you can see is actually 4 buses, so 3 and 4. So you can actually at once know that this will be a 4x4 matrix for the Ybus. We know that we want to develop the admittance bus for load flow, or the Ybus. The set bus we will use more on the fault calculation later in this course. So the first thing you need to do is to take the inverse, as shown here, for all the values in the impedance bus system. And then you need the corresponding current sources from the voltage sources. So you see here now we have currents entering this small diagram. So the first thing you do is start to develop these equations from this set diagram. Let's start from the node 1, the first bus. And then we have a current equals Y10 V1 plus we have Y12. Now the voltage drop V2. And then plus Y13. Voltage drop V1 minus V2. Like this. Yes. Oh, today. And then for node 2, we have the current 2 equals now the Y20. Same again, Y12, V2 minus V1. Now it's opposite, and then plus Y23, V2 minus V3. We need to take for node 3 and 4 also. Here we don't have a current source. So we write the equations V3 minus V2 plus Y13 Yes, I think that will be right. And then we take also the node 4. Here is also no current source, so Y23. Oh, sorry. You see that now we are here in this bus. So it's actually the Y34 we are looking for now. Y34 V4 minus V3, like this. So here's the for equation for 4 nodes from the admittance diagram. So you see, for example, for the node 1, you have then this, then we are here, node 1. Then you have this, the self admittance, we can say. And let's take here, it's first part here. So what's happening here? And then we have the between bus 1 and 2, this one. And then we have between y1 and 3, like here. So this is just be very consistent and be careful when you do this to get the right expressions. Now we actually rearrange these equations. And let's take the first one. Okay, sorry, black. Black here. Y1 equals now, and then we sort the admittances related to V1. Y1 plus Y like this, and this is related to V1, then minus 5 to 3. Minus, let's say, minus y12, yes. Yeah, that would be right, I think. Yeah, I sorted it out. And then we will have the current second node. We'll have minus y12 v1 plus like this, 2. And v3. And then we take the next one. Now we collect y13 in the node 3, yeah. Minus y13. Let's see. v1 minus y3. Now we have in the position 3 y13 2 3. Oh, sorry. Take that again, I think. 1 3 plus y2 3 plus y3 4, and then times v3. Now we also have the minus y3 4 v4 also here, and then the final 0 equal minus y3 4 v3 plus y3 4 3 4, yeah, v4, like this. So now we have rearranged it based on the voltage positions. So if you see now we have v1 here, v2, v3, v1, v2, v3, v1, v2, v3, v4, v3, v4. Another thing is that, of course, this, let's see if you take this, these 3 admittances will then be represented as the self y1, 1, like this, and this here. Okay. Take off here will then be y22, and then the same. Let's see here. And actually this will be then the y4, the sum of all admittances related to plus 4. Yeah, great. So we have come so far. Let's now start to put in some numbers. Let's do, now I have the admittance diagram here. So let's start from the self-admittances. So we can start, let's take the black one. One is then equal to, as I said below, above y10 plus y12 plus y13. And then we have the numbers up there. We have the minus j1 plus minus j 2.5. Then we have plus minus j5 equal to minus j8.5. So that's the y11, y22 equals y20 plus y12 plus y23 from up here. Then we have the values. Let's see it. So this is minus j 1.25 and plus minus j 2.5 plus minus j 5 equals minus j 8.75. Yes. Let's take the last one, y33 equals y34. No, sorry, that was wrong. Let's take it again. The y13 was, let's see, y13 plus y23 plus y34 equals minus j5 plus minus j5 plus minus j12 equals minus j22.5. Like this, and then we have the last one, y44 equals then y34 equals minus j 12.5. So remember that what we are actually doing now is to bring out this Ybus. So let's, maybe we can start to draw it up here like this. And then we have, we have the on the diagonal, we have these values, y11, y22, y23, 3, and y44. So we can start to fill that in, because now we have calculated those. So minus j 8.15, and then we have minus j 8.75, then we have minus j 22.5, then we have minus j 12.5. So I could probably, let's have a small pen here. Try to divide these matrices. Like this. So we can start to write then the Ybus equals this matrix. Remember that we can have positions, so we can call it position 1, 2, 3, 4, 1, 2, 3, and 4. So then the first one is y11. Follow that. Now let's take the mutual admittances, as we call it. So, and here we can just also remember before we start that for the mutual we'll have the yij equal yji. However, it will be minus yj. So it's opposite. That's important. And let's then start with the let's go a little bit down. y12 can we write as the y21 minus y12 equal. Then we have let's take it fast now, y13 and y31 equal minus y13 0 my y23 equal y32 equal. Like this, and then you can of course see now that this has plus values. However, on the you get negative on the diagonal, as you can see. Then we can put up the full equation as we will have it for the currents. Remember that now there are no. Let's take this and take have a little bit bigger. No connection between bus 1 and 4, for example. So then you have y14 equal y41 equal 0. You also have that y24 equals y42 equals 0. So that means we will get quite many zeros in a larger system like this. We in the general matrix form, we know that the position will be y11, y12, y13, and y14. Second, y21, 2, y23, y24, y31, y32, y33, and y34, y for 1, y for 2, y for 3, and finally y for 4. This is a 4x4 matrix for this system. So then you can see that this first number is the row and the second is the column. So, and also this is what we said before, this is what we call the diagonal, and it's symmetric along this diagonal, and we need to actually to store what we call the upper triangular here when you solve this, and it's called like a nodal admittance matrix. So we have also many off-diagonal elements become 0, such as I said here, this y1 4 4 1 is 4, all becomes 0 here and here, and then we have y 4 1 and 1 4 and this. So that means that we will have here 0 0, and we will have 0 0. Then we can also fill in for the other one. We have here, 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 and here. So the 1 2 is J 2.5, J 5.0, and in this we'll have J 2.5 again. Okay, a little bit not so good space here, but you can also see on the in MATLAB example how this will be developed. 3.0, 5.0, and 12.5, 12.5. Yeah, like this. So we are now then finally developed this Ybus matrix for this small diagram, as you can see here. So this is a very neat and okay way just to get this done. Please now open the MATLAB scripts in Canvas and try to go through the MATLAB example, so we can also verify it there.